Chain rule part one. We have a function z equals x squared plus 2xy, but then x is a function of t and y is a function of t. It's quite often useful to figure out how z is changing with respect to t. So that's our first question. Well, there's actually two methods. First of all, we can say z equals, for x we can substitute 2t squared, and then plus 2 times 2t times 3t, and we end up with 4t squared plus 2 times 2 is 4 times 3 is 12t squared, and that's equal to 16t squared. And then dz dt is just simply 32t. Simple as that. It's just a calculus 1 derivative. The second method is we can draw a tree diagram. Z is a function of x and y, and also x is a function of t, y is a function of t. And you can think of each of these paths as representing a partial derivative. And so we can generate a formula dz dt equals partial of z with respect to x dx dt plus partial of z with respect to y, okay, ran out of room here, times dy dt. We generally don't call this a partial because there's only one variable here. So we get dz dt equals partial of z with respect to x is 2x plus 2y times dx dt is 2 plus partial of z with respect to y is 2x times dy dt, which is 3. Now the problem is, the first case we had 32t, but here we have something as a function of x and y. We can simplify this. 2x times 2 is 4x plus 6x is 10x plus 4y. And of course we can substitute. 10 times x is really 10 times 2t plus 4 times y, which is 3t. And you'll see that's 20 and 12 is 32t. And that's the same answer. Those are two primary methods of finding that. So here we have z is equal to x squared plus xy. X is u plus v, y is u plus v. We want to find partial of z with respect to u and partial of z with respect to v. And again, we can use two different methods. We can substitute. Z equals x squared becomes u plus v squared, and then plus x, which is u plus v, times y, which is u minus 2v, and that's equal to u squared plus 2uv plus v squared plus u squared, and this minus 2uv plus uv is minus uv minus 2v squared, v times negative 2v, and let's see, uv, we get 2u squared plus uv minus v squared, combining like terms, and then partial of z with respect to u is equal to 4u plus v, and partial of z with respect to v is equal, that term zeroes out, u minus 2v. Okay, let's make a note of that. Z sub u is equal to 4u plus v, z sub v is equal to u minus 2v. Now let's show you a second method. We can make a tree diagram. Z is a function of u or x, sorry about that, and y. X is a function of u and v, and now we can write out partial of z with respect to u. There's two different ways in which you can get to this. Z sub x, partial of x with respect to u, plus z sub y, partial of y with respect to u. And in this case, let's go ahead and calculate z sub x is equal to 2x plus y. X sub u is equal to 1. Plus partial of z with respect to y is x times y sub u is 1. And like before, we want to get this in terms of u instead of x and y. So that's 2x plus x. You can write that as 3x plus y. And we can substitute 3 times x, which is u plus v, plus y, which is u minus 2v. And we get 3u and u is 4u. 3v minus 2v is plus v. Okay, guess what? That matches. So I guess we're correct. Second of all, we want to find z sub v. You can use this subscript notation if you want. That's equal to z sub x, x sub v, plus z sub y, y sub v. And z sub x, 2x plus y. X sub v is 1. Z sub y, it turns out, is equal to x times y sub v is at negative 2. And we can simplify 2x minus 2x, that just goes away. And guess what? We just get y. Okay, and of course, we know that y is u minus 2v. And that's what we got right there. So that's our first video for the chain rule. We'll be back with one more question in the second video.